Something just happened in the middle of Texas cattle country that the people who live there will tell you is never supposed to happen at all. Not tornadoes, not hail the size of baseballs, not the kind of violent spring supercells the Panhandle has learned to live with for generations. This time, the danger did not come from the sky. It came from directly underneath their homes. In the pre-dawn darkness of Thursday morning, a magnitude 5 earthquake ripped through a quiet stretch of ranch land in the Texas Panhandle, and according to the United States Geological Survey, it now stands as the strongest earthquake instrumentally recorded in that region in more than 100 years. And here's the part that should make you lean in a little closer. Days later, scientists still cannot tell you with confidence what actually caused it. Stick with this video until the end, because what is buried underneath the Texas Panhandle is far older and far stranger than almost anyone living above it realizes, and the competing explanations for what just happened there do not agree with each other at all. Start with the setup. The earthquakes struck at 5:21 in the morning local time, centered in rural Roberts County, roughly 24 miles southeast of the small town of Miami, Texas, in the open country between Pampa and Spearman, not far from the Oklahoma border. This is about as remote as the American heartland gets. Flat wheat fields, cattle operations, pipeline routes, and a scattering of small towns where almost everyone knows everyone else. It is a place built to withstand wind, drought, and hail. It is not a place where anyone goes to bed thinking about seismic waves. And yet, at 5:21 that morning, the ground itself became the threat. The rupture occurred at a shallow depth of only about 3.5 miles beneath the surface, and that single detail matters enormously because shallow earthquakes lose far less energy on their way up. The shaking arrives at the surface sharper, louder, and more violent than a deeper event of the same size ever would. That is exactly why this earthquake did not stay a local story. The shaking rolled across the entire Texas Panhandle, rattled Amarillo, and kept going, reaching all the way into Oklahoma City and Tulsa. With additional reports coming in from parts of New Mexico, some residents who felt it in Oklahoma City were nearly 250 miles from the epicenter. Think about that distance for a moment. That is like an earthquake in one country being felt in the capital of another. In Pampa, residents described shaking that seemed to go on, with one local telling reporters she was certain it lasted 20 seconds, maybe 30, if not longer. People described their beds moving underneath them, their homes creaking and groaning, and items rattling on shelves in the dark. One county judge in the region, who also serves as the local emergency management coordinator, admitted that his cat woke him up before the shaking itself did, because the animal sensed something wrong moments before the humans in the house understood what was happening. For a region whose emergency plans are written around tornadoes and winter storms, this was a completely unfamiliar kind of morning. Local officials openly acknowledged that their counties do not even have a formal protocol for earthquakes, because until this week, nobody believed. They seriously needed one. Now, here is where the story stops being a simple news event and starts becoming a genuine scientific puzzle. When most people hear the words Texas and earthquake in the same sentence, their minds jump immediately to one explanation: oil and gas activity. And that instinct is not unreasonable because parts of Texas really have experienced human-triggered earthquakes, and we are going to examine that possibility honestly in this video. But the officials and scientists responding to this specific event have been noticeably, almost conspicuously careful. The USGS identified the event as the likely main shock of a new earthquake sequence, but pointedly declined to assign a cause. A meteorologist with the National Weather Service office in Amarillo confirmed that Thursday's quake was significantly stronger than anything the region typically experiences, and noted that minor fault lines beneath the Panhandle are capable of producing weak to moderate earthquakes on their own. In other words, the people closest to the data are refusing to give the public the easy answer, and that refusal is itself a signal. And when experts hesitate this visibly, it usually means the evidence is pulling in more than one direction at once. And the evidence here pulls in at least 4 different directions. There's an ancient buried structure underneath this exact part of Texas, a scar in the continent itself that formed roughly 500 million years ago, long before anything walked on land. There's a century-old record of earthquakes in this same corner of the Panhandle that most Texans have never heard of. There is the modern, well-documented science of industrial activity, waking up sleeping faults. And there is a 4th possibility that almost nobody in the media is saying out loud. Before this video is over, you are going to understand all 4, and you are going to see why the most honest answer might also be the most unsettling one. But first, we need to go back in time, because this ground has shaken before and the records left behind are stranger than the earthquake itself. To understand what happened on Thursday, you first have to understand something that almost nobody outside a small circle of geologists knows. The Texas Panhandle has been shaking, quietly and regularly, for over a century. This was not the first significant earthquake in the region's recorded history. It was, depending on how you measure it, the fourth. The historical record maintained through the National Weather Service lists 3 earlier earthquakes at or above magnitude 5 in the Panhandle, one near the town of Panhandle in 1925, estimated at magnitude 5.4, one near Borger in 1936 at magnitude 5.0, and one near Dalhart in 1948, measured at 5.2. A scattering of smaller but still noticeable events followed in the decades afterward. So when you hear that this week's earthquake was the strongest in more than 100 years, a reasonable person immediately asks an obvious question. If a 5.4 struck in 1925, how can a 5.0 or 5.1 in 2026 be called the strongest ever recorded? The contradiction ran through nearly every headline this week, and the answer turns out to be one of the most interesting parts of this entire story. Here is the uncomfortable truth about that 1925 earthquake. It was never actually measured. In the 1920s, this remote stretch of the Panhandle had no seismograph anywhere near it. There was no instrument sitting in the ground recording the waves as they passed, so scientists of that era did the only thing they could do. They reconstructed the earthquake after the fact, using human testimony. They mapped where people reported feeling the shaking, how strongly they described it, where plaster cracked, where chimneys were damaged, and from that patchwork of letters, newspaper accounts, and damage reports, they worked backward to an estimated magnitude. That estimate may, well, be close to the truth. But it is fundamentally a number built from human memory, not from instruments. Thursday's earthquake, by contrast, was captured in real time by a modern seismic network reading the ground directly. So when the USGS and news outlets describe this week's event as the strongest ever recorded in the Panhandle, what they really mean is the strongest ever measured by an instrument. Once you separate an estimated earthquake from a measured one, the contradiction in the headlines dissolves. It is a bit like arguing over whether an old hand-drawn portrait or a modern photograph shows the more accurate face. And that distinction quietly reveals something bigger. The seismic history of this region is blurrier and less complete than the confident headlines suggest, which means the ground beneath the Panhandle has almost certainly done things over the centuries that no record ever captured at all. Now follow the story downward, because the next question is the one that matters most. What is actually sitting underneath all of that flat, quiet wheat and cattle country? The answer is genuinely ancient. According to the National Weather Service office in Amarillo, most Panhandle earthquakes occur near the boundary between 2 enormous buried structures, the Amarillo-Wichita Uplift and the Anadarko Basin. Strip away the surface and you find the remains of a colossal geological drama that played out roughly 500 million years ago in the early Cambrian period. Back then, long before dinosaurs, long before forests, long before anything with a spine had crawled onto land, the North American continent began to do something extraordinary in this exact region. It started to tear itself apart. A rift began opening in the crust, the same process that today is splitting East Africa and that once opened the Atlantic Ocean. If it had continued, the land that is now the Texas and Oklahoma Panhandle country could have become the floor of a new sea, but the rift failed. For reasons scientists are still working to fully explain, the tearing stopped partway through, the crust healed over, and the continent stayed whole. What that failure left behind is the key to this entire story. A failed rift does not simply vanish. It leaves a deep, buried scar, a zone of ancient faults and fractured rock that is permanently weaker than everything around it. That scar has been lying underneath the Panhandle ever since, silent for stretches of time so long that entire mountain ranges rose and eroded away above it. And here is where the pattern turns genuinely fascinating. Stress never stops accumulating inside a continent. The North American plate is constantly being squeezed and pushed by forces acting on its distant edges, and that stress spreads through the interior like tension through a sheet of glass. When enough of it builds, it releases at the weakest available point. In the Panhandle, the weakest available point is that same half-billion-year-old scar. This is the first and currently leading natural explanation for Thursday's earthquake, an ancient failed rift briefly waking up entirely on its own, with no human involvement whatsoever, simply geology operating on a timescale that makes a human lifetime look like a single frame of film. Early analysis suggests Thursday's event was primarily a strike-slip rupture, 2 blocks of crust grinding sideways past each other, which is exactly the kind of motion these buried basement faults are capable of producing when regional stress finally overcomes them. But that is only the first of the 4 explanations. And the next 2 involve human hands, because it turns out this is not the first time people have asked whether the oil underneath the Panhandle might be connected to the shaking above it, and the historical evidence on that question is far older than fracking itself. The second explanation is the one almost nobody in this week's coverage is talking about, and it reaches back nearly a century. The Panhandle is not just ranch country, it sits on top of one of the older oil and gas producing regions in Texas, with fields that were being aggressively drilled as far back as the 1920s and 1930s. And when researchers went back and studied the region's historical earthquakes, they noticed something that is difficult to dismiss as pure coincidence. Several of those early and mid-century events, including quakes in the 1930s and again in the decades after, occurred directly above or near petroleum fields that were under active production at the time. Published research has presented evidence that a number of early to mid-20th century earthquakes in Oklahoma and Texas were likely induced by fossil fuel production or the injection of wastewater, which means the idea of human-triggered earthquakes in this part of the country is not a modern controversy at all. It may be almost as old as the oil industry itself. But the honest caveat matters here. The instruments of that era were primitive, and scientists studying those old events openly acknowledge they could not pin down the precise depths and locations with the accuracy needed to prove the connection. So explanation number 2 remains a genuinely open question, a suggestive pattern rather than a settled verdict, hanging over the region's history like a question mark that never got erased. That brings us to explanation number 3, the one your mind probably jumped to the moment you heard the words Texas and earthquake together. Modern oil and gas operations, and specifically the practice of injecting wastewater deep underground. Let's be precise about this, because the details matter. The drilling process, including hydraulic fracturing, produces enormous volumes of salty, contaminated water that comes back up with the oil. That water has to go somewhere, and the industry's solution is to pump it back down into deep disposal wells. The process involves injecting large quantities of contaminated, salty water deep underground. The science on what that can do is no longer in dispute. The injected fluid raises pressure inside deep rock formations. That pressure migrates outward, and when it reaches a fault that was already loaded with natural stress, it can effectively unclamp it. Earthquakes in the Permian Basin of West Texas have been clearly linked to exactly this kind of industrial activity, and Oklahoma's dramatic earthquake surge in the last decade was so firmly tied to injection that regulators forced companies to shut down wells and cut volumes. And there is a statewide pattern that makes the question unavoidable. According to USGS data, 85% of all Texas earthquakes at magnitude 2.5 or greater have occurred since 2020. Something has changed in Texas, and it is not the geology. So is that the answer for Thursday morning? Here is where the responsible version of this story separates from the sensational one. The officials and scientists closest to this specific event have been strikingly cautious, and their caution is grounded in real analytical standards. When researchers investigate whether an earthquake was human-induced, they do not guess. They examine the depth of the rupture and compare it to the depth of nearby disposal wells. They map the exact location against active injection sites. They study the timing, asking whether seismicity in the area rose after injection volumes rose. And they compare the fault that broke against the region's known natural stress field. When those factors line up, the case becomes strong. So far, for this particular earthquake, they have not lined up cleanly. The Panhandle is not the Permian Basin. It does not have the same density of high-volume disposal wells. It does not have the same documented pressure history. And a magnitude 5 release is at the upper end of what injection-triggered events typically reach. That is why the USGS declined to assign a cause, and why the most knowledgeable voices keep repeating the same phrase, more data is needed. Meanwhile, the industry itself is treating the quake as a threat rather than an accusation. Local officials confirmed that pipeline companies activated their earthquake protocols within hours, sending crews to check lines around the epicenter and verify pressure across the network, because in a region laced with energy infrastructure, the immediate danger from shaking is not falling buildings. It is what runs beneath the ground alongside the faults, which delivers us to explanation number 4. And you might expect this one to feel like a letdown. It is not. Explanation number 4 is that nobody currently knows, and in my view, it is the most honest and most important answer of the 4. Within hours of the earthquake, the scientific messaging was consistent. Determining the true cause of an event like this takes weeks or months of careful data collection, aftershock mapping, and modeling, and accumulated tectonic stress is fully capable of reactivating an ancient fault with zero help from the surface. In science, the words we do not know yet are not an evasion. They are the sound of people refusing to pretend. 4 explanations, all still technically alive. An ancient scar waking on its own. A century of old oil fields with an unresolved question mark. Modern injection with strong science but weak local evidence. And honest uncertainty. But there is one more piece of this story, and it is the one that genuinely stopped me while researching it, because that buried scar under Texas has a nearly identical twin under another part of America, and that twin has a very violent past. Here's the detail that elevates this from a regional news story into a piece of American geological history. The failed rift buried beneath the Texas Panhandle is not unique. Geologists have long pointed out that it shares its fundamental structural blueprint with another ancient failed rift buried deep under the central United States, the Reelfoot Rift, which sits directly beneath the New Madrid seismic zone where Missouri, Arkansas, Tennessee, and Kentucky come together. And if that name means nothing to you, it should. In the winter of 1811 and 1812, the New Madrid zone produced one of the most violent earthquake sequences ever documented in the continental United States. Multiple enormous earthquakes struck within a span of months, powerful enough to ring church bells hundreds of miles away on the eastern seaboard, to permanently rearrange sections of the local landscape, and to generate accounts from that era describing the Mississippi River appearing to briefly run backward. The human toll was limited only because almost nobody lived there at the time. If an identical sequence struck that same region today, with its modern cities, bridges, pipelines, and millions of residents, the outcome would be catastrophic on a scale America has never experienced from an earthquake east of the Rockies. Now, let me be absolutely clear about what I am saying and what I am not saying. No scientist is predicting a New Madrid-style disaster in Texas. Nobody serious is suggesting the Panhandle is due for anything remotely on that scale, and this channel is not going to pretend otherwise. What geologists are pointing out is narrower and honestly more profound. Both regions were built from the same recipe. A continent that started to tear apart hundreds of millions of years ago, stopped and healed over a deep zone of weakness that never went away. One of those scars happens to lie under the Mississippi River Valley. The other happens to lie under Texas wheat fields. The recipe is the same, only the scale and the timing differ. And that shared heritage is the real lesson of this week, because it means the Panhandle's usual silence was never the same thing as stability. So what happens now? The forecast, as far as one exists for earthquakes, looks like this. The USGS has identified Thursday's event as the likely main shock of a sequence and expects smaller aftershocks over the coming week, potentially including up to 5 at magnitude 3 or higher, which would be large enough to feel near the epicenter, while the chance of an aftershock larger than magnitude 5 within the week sits below 1%. Aftershock activity will decay with time, though a single larger aftershock could temporarily reset that clock. Confidence in that outlook is moderate, because aftershock forecasting is statistical, not deterministic. Damage risk remains low for a simple reason. Almost nobody lives in that specific stretch of the Panhandle. No structural damage or injuries have been reported, and vast state containing multiple separate seismic zones, some ancient and natural, some tied to modern industry, and 2 of them happen to speak on the same day. That is coincidence of timing, nothing more. Step back and look at the statistics, and Thursday stops looking like a freak event and starts looking like an appointment. 4 earthquakes at or near magnitude 5 in. Roughly a century works out to something in this class, striking the Panhandle about once every 25 to 30 years. The last one was 1948. By that arithmetic, this region was not overdue for a surprise. It was overdue for exactly this. Push the threshold higher toward the mid-5s, and you are looking at something closer to a once in 50 to 100 year event. Baudelaire, magnitude 6 would be rarer still, on the order of centuries. Nobody could have told you the date in advance, because that is the one thing earthquake science cannot do. But the hour was always going to strike eventually. So here is where this story stands, as of right now. The strongest instrumentally recorded earthquake in Panhandle history is a settled fact. The cause is not. 4 explanations remain on the table: an ancient rift moving on its own, a historical question mark hanging over old oil fields, modern injection science that fits the state but not yet this spot, and the honest admission that the data is still coming in. Underneath all of it lies a half-billion-year-old wound in the continent, sharing its blueprint with the most violent earthquake zone in the American interior, patient in a way nothing living can comprehend. What to watch next is simple: the aftershock pattern over the coming weeks, and whether investigators eventually link the rupture depth to anything human. If you found this as fascinating as I did, subscribe, because this channel tracks exactly these underreported natural events every week, explained without exaggeration. And tell me in the comments, honestly, had you ever heard of the Reelfoot Rift or the New Madrid earthquakes before today? I will bring you an update the moment anything meaningful develops under the Panhandle.